Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aiman bin Zainal. This is my video presentation for BDP II that entitled as Investigation the Property of the Distribution Power Source for Dual Direct Current Voltage. So here is my poster for this presentation that consists of introduction, objective, problem statement, research methodology, result and discussion, lastly conclusion, and also a reference for this project. Lightning detection system. We know that lightning carries a high voltage and the current is happening due to the imbalance charge between the storm and the grounding. The light from the flash is everywhere that could make a neutralized charge, and the lightning strike produce the electric and the magnetic that also known as electromagnetic. So my study is a continuity from the previous that having a problem. For introduction, this study is to propose and carry out the features or the method how to analyze the compatible of the electromagnetic capability of the module. So I'm like to propose some module that maybe help the system that might happen, the problem that happen from the system. So the statement problem is power supply that distribute for the sensor. All sensor in the system associate a noise that not good for the system, and probably from the switching action which is from the L3122. So we like to know more detail about that in this study. This project consists of three main of the objective. Firstly, replacing the power traco for the switching action. Secondly, analyzing and construct the IC circuit for the capability of electromagnetic for the system. Lastly, evaluating the system or the sensor after analyzing and replacing this traco power. Next is research methodology, which is 5 main point for this methodology, which is planning, analysis, design, implementation, and maintenance and support. First, planning. We have done this in earlier of the BDP, which is planning. What we want to do, what we want to have, what we expected for this study. This is how planning analyze. After we are planning, we design a circuit that for the EMC capability of the circuit can reduce for the system, especially for the traco for power output, which is giving a positive and negative 12 volt and negative volt. So the design is, the idea is to reduce the noise that occur for the output going to the sensor. That's the main idea. Then design consists of the small electronic devices, which is resistor, inductor, and also capacitor. In this case, we are using that to design. That's how it's work. The characteristic of the component that which is helping to reducing the EMC of the noise in this circuit, especially in traco power, and also the others three representing or replacing to replace traco power that we suggest to. Next, implementation. The simulation we have done for this particular of studies to ensure that and prove what actually happened. Is it a traco having a problem, or the sensor, the IC at the sensor having a problem? So we need to figure out in this implementation using a ORCAD. Then maintenance and support to analyze and conclude to maintain that and support a data for what we got from the simulation. That's how the research methodology we are doing. Next is result and discussion. For this part, I'm speak to the two part, which is A and B. Part B we have a part B because something occurred in part A that we can't to solve a problem in a short time. So the part B is a simulation that we are planning at the first phase, which is a charcoal power with a CUIN module, XP power module, and also 60 XP power module that we want to try to do a simulation and to figure out how it actually works for this system and the characteristic for each module. So, however, during a simulation, we having a difficulty like a missing file, a missing library, especially because of the manufacturer for the technical service say that they can't to share the library of this module at certain module. So maybe that's the limitation at this particular of study. So yep, that is for part A. And for part B, we are doing an assumption like design a circuit that producing a noise with the noise that we expected that producing from the charcoal power itself. So it's connected to the sensor for the magnetic field that designed by the Fikri from development investigation itself, and try to figure out how it's the output waveform give. But at the end, something might occur and it's not like what we expect to. So let's start the simulation. This is a general features of the lightning detection system. I would like to talk about my main idea of my project. I'm only focusing on this particular part, which is a charcoal power that distribute a positive and negative 12 volt with a Vin 12 VCC. This part has been limited with a 3 amp fuse. This is a positive terminal source and this is a negative terminal source. Next, for the lightning sensor for the electric field, and this is a lightning sensor for the magnetic field specific for the nodes and short for this looping here. Last, for the connection for the measuring that connected to the channel 2. This part to trigger the channel for the electric field, and this part for the magnetic field with a specific for the nodes and sort. Firstly, this is a AC circuit using a R resistor which is 100 ohm. To establish its to use for the AC circuit with a noise we are set up. So to know and measure, we want to know the peak and the lowest from this waveform. Try to zoom to make it very clear to be measured. Set a cursor and the peak giving a 12.283 voltage and the lowest giving a 10.56 E. So the gap between these two peak and the lowest is big. The second simulation is a AC signal, but we are using a 10 kilo ohm for its resistor. Here is the output waveform for the AC signal that are given. So we try to zoom at the 30 millisecond of output waveform. So get to near zoom. So we try to read the peak and the lowest Here is the most beautiful one, and the peak we are finding that giving a note that for this circuit we are designing having a waveform with a big gap, not a small gap, 11.696, and the lowest giving the more gap between the highest and the lowest, the better circuit we are choosing, 11.572, which is very slightly different between this peak and the lowest. So we do not choose the 100 kilo ohm resistor because we assume that we expected the noise with a peak. This is a magnetic field circuit that combined with a AC circuit signal with a noise that we are designed for. Connecting to LMH6639 with a 5 volt voltage impulse. So here is the output waveform that we got. We try our best to find a best output waveform which is having a noise too, but at this simulation we're providing a very beautiful output waveform that we see from this blue output waveform. Let me zoom. So here there is a very beautiful line that giving a 4.99 peak input voltage impulse at this one, and also for this consistent 5 volt for this impulse voltage. So we can't notice and find out a noise that might occur at this circuit. So that's all from me. For the conclusion is the noise is always remain in the system. We can't reduce it until it becomes zero, but we should reduce for the purpose and control, and it's important for the system, especially for the system lightning detection system, to make sure it's working very efficient and to maintain its endurance. So last, there is the main reference for this study, which is development for lightning detection system using combination of electronic field and magnetic field from Fitri 2019, and the latest one is from the Zjing with his friend, which is design a flight back high efficiency switching power supply. That the latest one 2021, that's very help during my writing. Yep. That's all from me. My name is Zainal. Thank you for watching.